Welcome, curious minds, to a world of knowledge and discovery. Welcome to another exciting video where we'll be shedding light on Kenneth Sims, geologist. Kenneth W. Sims, born 1959, is an American professor of isotope geology in the Department of Geology and Geophysics at the University of Wyoming. Sims operates the University of Wyoming High Precision Isotope Laboratory. Professor Sims is married, has 2 children, and lives in Laramie, Wyoming. As we venture forward, let's take a closer look at research overview and its impact on our understanding. Sims is a National Geographic explorer well known for using his technical mountaineering skills to collect geological samples from remote locations across the globe, including sampling molten magma from lava lakes deep within volcanic craters, collecting temporal sequences of lavas from high, technical ridges on the flanks of the world's tallest volcanoes, and using submersibles to obtain mid-ocean ridge basalts from the bottom of the Earth's oceans. Many of these adventures have been featured in National Geographic publications and documentaries, as well as numerous other media venues. Sims' research endeavors focus on obtaining hard-to-collect samples and then measuring unique and analytically challenging isotope systems to provide otherwise unattainable answers to societally relevant questions about Earth systems science. Sims' research applies a variety of isotopic techniques: U and decay series, cosmogenic nuclides, radiogenic isotopes, and non-traditional stable isotopes to address a wide range of topics in Earth and ocean sciences. Sims has published nearly 100 research articles in peer-reviewed scientific journals, including Nature and Science. These publications cover a wide range of topics: magmagenesis, differentiation and degassing, continental and oceanic crustal construction, planetary accretion and core formation, trace element partitioning, superficial weathering, paleoceanography, chemical oceanography, groundwater hydrology, water-rock interaction, fumaroic activity, volcanic aerosol formation and dispersal, serpentinization, natural rates of carbon sequestration, and shallow subsurface geophysics. Sims' major contributions are determining the timescales and dynamics of magmagenesis and volcanic processes. Sims' research is funded by the U.S. National Science Foundation, National Geographic Society, the U.S. Department of Energy, Woods Hole Oceanographic Institution, and the University of Wyoming. With the groundwork laid, let's now examine career and its connections to our previous discussions. Sims received a Bachelor of Arts in Geology in 1986 from Colorado College, graduating cum laude with honors. He completed an MSc at the University of New Mexico's Institute of Meteoritics in 1989, where his research focused on chemical fractionation during the formation of the Earth's core and continental crust. His Ph.D. was earned in 1995 from the University of California, Berkeley, where his research focused on magmagenesis in the Earth's mantle. Sims worked as a student and then as a guest scientist for the Isotope and Nuclear Chemistry Group at the Los Alamos National Laboratory, New Mexico. After completing his Ph.D., Sims was awarded the Woods Hole Oceanographic Institution WHOI Postdoctoral Scholar Fellow from 1995-1997. He was then hired onto the WHOI scientific staff in 1997, where he remained as a tenured research scientist until 2009. In 2009, Sims moved to the Department of Geology and Geophysics of the University of Wyoming, where he is now a full professor. Sims was a visiting CNRS Fellow at the Institut Universitaire Européen de la Mer IUEM, France in 2002. In 2016, Sims became a U.S. Fulbright Scholar and a visiting professor at the Instituto de Geofísica, Escuela Politécnica Nacional, Quito, Ecuador. In his current role at the University of Wyoming, Sims is involved in a variety of research projects, graduate and undergraduate teaching, and the supervision of graduate students. Sims is the University of Wyoming organizational lead for the Yellowstone Volcano Observatory. Sims has received various academic accolades for his research and public engagement. Additionally, Sims worked as a professional climbing instructor and high-altitude mountaineering guide for 23 years 1975–1998, including in Antarctica, Alaska, Mexico, and Peru. During this period, he pioneered many difficult first ascents around the world. Let's now zoom in on field work and uncover the hidden gems that lie within. Sims' field work, primarily funded by the National Geographic Society and the National Science Foundation (NSF), has crossed the globe from the bottom of the Earth's oceans to the top of its highest volcanoes. Highlights of Sims' field research include: as we progress, let's shine a spotlight on Antarctica and examine its intricate interplay within our topic. Sims has been to Antarctica 14 times since 1989. He has worked both as a guide for science parties funded by the NSF and NASA, including as a guide and reader for the NASA Domte rover project, and also as a principal investigator funded by the NSF to conduct research on the volcanoes of Ross Island and Mount Morning. In particular, Sims has worked and published extensively on Mount Erebus, the world's southernmost active volcano, including descending into its active crater numerous times to collect recently erupted lava bombs from its persistent lava lake. Sims' most recent expeditions have been to study the volcanoes Mount Bird, Mount Terror, and Hut Point on Ross Island, and also the volcanic cones on Mount Discovery. Let's now shift our focus to Democratic Republic of the Congo and explore the ways in which it shapes our perspective. Sims' expeditions to the Democratic Republic of the Congo were funded by the National Geographic Society to film 2 documentaries and by NSF for research related to volcano hazard assessment. In his research pursuits, Sims has trekked deep into the Virunga jungles to access a remote and often active volcano Nyamulejura, and he repeatedly descended into the active Nyamulejura crater to collect old lava flows from the crater walls and molten magma from the active lava lake. Get ready for an exciting part as we dive into Ecuador. Sims has conducted numerous expeditions into the Ecuadorian volcanoes. Funded by the National Geographic Society in 2014, Sims led a month-long expedition into the remote Sangay volcano 5,300 meters feet ASL, which is one of the highest and most continuously active volcanoes in the world. In 2016, while living in Ecuador for 6 months on a U.S. Fulbright scholarship, Sims conducted several 2-week expeditions to collect samples on the steep, glacially dissected flanks and high-altitude ridges of Chimborazo 6,263 meters feet ASL. Sims has also conducted and published NSF and UW-funded research on the volcanoes Reventada, Sumaco, and the Chalupas caldera. As we enter this new phase, let's analyze mid-ocean ridges from different angles and evaluate its significance. Sims has researched the petrology of mid-ocean ridges extensively. Sims worked on several research expeditions to 9 and East Pacific Rise aboard the WHO-operated research vessel RV Atlantis, utilizing the U.S. Navy-owned deep submergence vehicle DSB Alvin and other remotely operated DSL-120 and Jason and autonomous ABE vehicles to conduct his research. Sims has also sent his graduate students on research expeditions to the Colbeensie Ridge, the SW Indian Ridge, and Mid-Atlantic Ridge, and East Pacific Rise. In this chapter, we'll be shedding light on Yellowstone and its role in shaping our understanding. Wyoming is home to one of the world's supervolcanoes, Yellowstone, which also happens to host the world's most profound and visually stunning example of an active continental hydrothermal system. Since moving to Wyoming, Sims has been coordinating the introduction of novel geochemical and geophysical techniques to study Yellowstone's geohydrobiology, which is the study of how Earth, water, and life connect. Let's now venture into the realm of other locations and explore the fascinating intricacies it holds. Sims' research has also taken him to volcanoes in Italy, Mount Etna and Stromboli, Nicaragua Vulcan Mosoya, Iceland Hekla, Veistrika, Krafla, Hawaii Kiaya, Mauna Loa, Hololei, Mauna Kea and Helicula, and New Mexico Jebus Volcanic Field, Zuni Bandra, and Raton Clayton volcanic field. Sims has worked on problems related to serpentinization and carbonization in Samoa-Ophiolite of Oman and the Josephine Predicate in Oregon. Now, let's shift our perspective and explore public engagement from a different angle. Sims research and scientific expeditions have been featured in National Geographic Magazine October 2004, April 2011, GEO Magazine October 2012, 2017, National Geographic Explorer Kids October 2011, Oceanus Fall 2006, Popular Mechanics October 2006, New Scientist July 2008, December 2008, CNN Great Big Story, Mental Floss August 2013, The Children's Book Lover Scientists, Careers on the Edge of Volcanoes Sarah Latta, in Slow Publishing, Inc. National Geographic Television Man vs. Volcano, April 2011, One Strange Rock, March 2018, National Geographic Weekend Radio January 2015, Discovery Channel Against the Elements, Spring 2009, Volcano Time Bomb, December 2012, NHK Japanese Public Television Miracle Continent Antarctica, and Boston Museum of Science Volcanoes on the Verge. Sims contributes regularly to the National Geographic Explorers blog. With our curiosity piqued, let's embark on a dedicated exploration of special awards and honors and its fascinating intricacies. Source: Fulbright U.S. Scholar Award, Top 10 Teacher Award, University of Wyoming 2015 Extraordinary Merit in Research Award, University of Wyoming 2015 National Geographic Society Explorer Faculty Senate Speaker Award, University of Wyoming 2104 Meritorious Teaching Award, University of Wyoming 2014 Papadopoulos Fellow, Kincaid School, Houston, Texas 2012 Mellon Independent Study Awards, Woods Hole Oceanographic Institution 1999, 2001, 2006, 2008 Outstanding Graduate Student Instructor, University of California, Berkeley 1992 Esping Outstanding Senior Geologist, Colorado College 1986 Getty Oil Fellowship, Colorado College 1984. Now, let's dig deeper into significant publications and unveil the hidden treasures it holds within. Authors marked with an asterisk are graduate students working with Sims. Let's now venture into the realm of mantle dynamics and magma genesis and explore the fascinating intricacies it holds. Sims, KWW, S.J. Goldstein, J. Blickett Toft, M.R. Perfit, P. Keelman, D.J. Fornari, P. Michael, N.T. Morrill, S.R. Hart, D.J. DePaulo, G.D. Lane, and M. Jull 2002. Chemical and isotopic constraints on the generation and transport of melt beneath the East Pacific Rise. Geochimica et Cosmochimica Act at 66, 19, 3481 3504. DOI S2. Sims, KWW, M.T. Morrill, D.J. DePaulo, W.S. Baldridge, S.J. Goldstein, D. Clogg and M. Jull 1999. Porosity of the melting zone and variations in the solid mantle upwelling rate beneath Hawaii, inferences from Uerthera and Uerpa disquilibria. Geochimica et Cosmochimica Act at 63, 23, 4119 4138, DOI, /0. Sims, KWW and D.J. DePaulo 1997. Inferences about mantle magma sources from incompatible element concentration ratios in oceanic basalts. Geochimica et Cosmochimica Act at 61, 765 784. DOI, /9. Sims, KWW, D.J. DePaulo, M.T. Morrill, W.S. Baldridge, S.J. Goldstein, and D. Clogg 1995. Mechanisms of magma generation beneath Hawaii and Mid-Ocean ridges, UF and SMON isotopic evidence. Science, 267. DOI, /Science. Sims, KWW, J. Blickett Toft, P.R. Kyle, South. Pitchett, J. Blasane, P.J. Kelly, L. Ball, and D.D. Lane 2008. a senior and isotope perspective on the genesis and long-term evolution of alkaline magmas from Ebus volcano, Antarctica. Invited article to special volume on Mount Ebus in Journal of Volcanology and Geothermal Research, 177, 606, 618. Doi, Schvolgers. Sims, KWW, J. McLennan, J. Blackett-Toft, E. M. Mervine, J. Blasane, and Kelvin. Gromvold 2013. Short-length scale mantle heterogeneity beneath Iceland probed by glacial modulation of melting. Earth and Planetary Science Letters, 379, 146, 157. Doyer Jepsel. Waters, C.L., KWW Sims, M.R. Perfit, J. Blackett-Toft, and J. Blasane 2011. Perspective on the genesis of EMORB from chemical and isotopic heterogeneity at 9 and East Pacific Rise. Journal of Petrology, 52, 3, 565, 602. Doyer Petrologic. Alkins, L.J., KWW Sims, J. Prytulik, T. Elliott, North. Mattingly, J. Blackett-Toft, J. Blasane, Celsius. DeVay, D. Mertz, J.G. Schilling, and M. Morrill 2011. Understanding Melt Generation Beneath the Slow-Spreading Kolbinsi Ridge using U, Earth, and Upper Excesses. Geochimica et Cosmochimica Acted, 75, 21, 6,329. Dorjoke. In the following segment, we'll be examining oceanic crustal construction in greater detail. Sims, KWW, J. Blackett-Toft, D.J. Fornari, M.R. Perfit, S.J. Goldstein, P. Johnson, D.J. DePalo, and P. Michaels 2003. Aberrant Youth, Chemical and Isotopic Constraints on the Young Off-Axis Lavas of the East Pacific Rise. Geochemistry, Geophysics, Geosystems, 4, 10, 8621. Doyog. Sims, KWW, S.R. Hart, M.K. Reagan, J. Blasane, H. Stordigal, Ison, G.D. Lane, L.A. Ball and J. Andrews 2008. Earth era and upper constraints on the ages and petrogenesis of Valilu and Mulamalu lavas, Samoa. Geochemistry, Geophysics, Geosystems, 9. Doyek. Waters, C.L., KWW Sims, E. M. Klein, S. M. White, M. K. Reagan, and G. Gerard 2013. Cell to surface, linking young off-axis volcanism with subsurface melt at the overlapping spreading center at an East Pacific Rise. Earth and Planetary Science Letters, 369, 370, 5970. Doy Jepsel. Standish, J.J. and KWW Sims 2010. Young Volcanism and Rift Valley Construction at an Ultraslow Spreading Ridge. Nature Geoscience, 3, 4, 286, 292. Doy, Ernjo. Son, R.A. and KWW Sims 2005. Bending as a Mechanism for Triggering Off-Axis Volcanism on the East Pacific Rise. Geology, 33, 2, 9396. Doy, Erg. Waters, C.L., KWW Sims, S. Isal, J. Blackett-Toft, N.W. Dunbar, T. Planck, R. Som, and M. Atili 2013. Recent volcanic accretion at 9 and East Pacific Rise as resolved by combined geochemical and geological observations. Geochemistry, Geophysics, Geosystems, 14. Doy, Urge. Brace yourself for an enlightening exploration of shallow magmatic processes as we dive into its profound implications. Sims, KWW, South. Pitchett, M.K. Reagan, P.R. Carl, H. Doolayover, North. Dunbar, J. Prytulik, G. Sawyer, G. Lane, J. Blackett-Toft, P. J. Gathia, M. A. Charette, and T. R. Elliott 2013. On the timescales of magma genesis, melt evolution, crystal growth rates, and magma degassing in the Ebus volcano magmatic system using the U and Earth Decay Series. Journal of Petrology, 54, 2, 235-271. doi, petrologides. Radin, M.K., K.W.W. Sims, J. Enrich, R.B. Thomas, H. Cheng, R.L. Edwards, G.D. Lane, and L.A. Ball 2003. Timescale of differentiation from Mafic parents to rhyolite in North American continental arcs. Journal of Petrology, 44, 9, 1703-1726. doi, petrologide Giamanco, S. K.W.W. Sims, and S. M. Neri 2007. Shallow rock stresses and gas transport at Mount Etna, Italy monitored through urn and soil co-emissions in soil and fumaroles. Jokum. Jofes. Joses, 8. Doyerk. Chakrabarti, R. K.W.W. Sims, R. Bosu, M. Reagan, and J. Drew 2009. Timescales of magmatic processes and eruption ages of the Nyiragongo volcanics from Earth era up disequilibria. Earth and Planetary Science Letters, 288. Dorjepsel. Ruby, O. K.W.W. Sims, and B. Borden 2014. Earth equilibrium in arc magmas and implications for the timescales of mantle metasemitism. Earth and Planetary Science Letters, 391, 146, 158. Dorjepsel. Ruby, OKWW Sims, North. Barley, M. Reagan, and J. Eichenberg 2015. Timescales of degassing and conduit dynamics inferred from era disequilibria in Volcan de Colima 1998-2010 and Disitic magmas Karichi, L. and Blundy, J. D. Id's Chemical, Physical and Temporal Evolution of Magmatic Systems. Geological Society, London, Special Publications, 422, Topoigersp. Cooper, K. K.W.W. Sims, J. M. Eiler, North. Banerjee, 2016. Time scales of storage and recycling of crystal mush at Krafla Volcano, Iceland. Contributions to Mineralogy and Petrology, 171, 654. doi 1612-67-3. Garrison, J. M., K.W.W. Sims, Miogodzinski, I.D. Escobar, South. Scott, P. Mothers, Patricia, M. L. Hall, P. Ramon 2018. Shallow level differentiation of phenolitic lavas from Sumaco Volcano, Ecuador. Contributions to Mineralogy and Petrology, 173, 6. DOI, a 1714-31-4. Now, let's shift our perspective and explore ocean chemistry and processes from a different angle. Pitchett, S. K.W.W. Sims, R. Franois, J. F. McManus, South. Brownlegger and Fahrenheit. Albany 2004. Low export production during glacial periods in the equatorial Pacific as derived from Earth measurements in deep-sea sediments. Paleoceanography, 4023. doi, Pay. Owens, S.A., K. Obusula, Sims 2011. Re-evaluating the salinity relationship in seawater, implications for the Earth disequilibrium method. Marine Chemistry, 127, 20 pages. doi Markham. Arendt Casmac, Kelvin. W. W. Sims, South B. DOS, Celsius. Sheik, East. I. Stevenson 2018. Greenland subglacial water and proximal seawater chemistry, implications for seawater on glacial interglacial timescales. Geochimica et Cosmochimica Active, 225, 100-115, doi Jog K. As we transition, let's shed light on crustal dynamics and processes and its relevance to our ongoing exploration. Sims, K.W.W., R.P. Ackett, Jr., Fahrenheit. Ramos, R.A. Son, M.T. Morrell, and D.J. DePaolo 2007. Determining eruption ages and erosion rates of quaternary basaltic volcanism from combined U-series disequilibria and cosmogenic exposure ages. Geology, 35, 471, 474, doi Gear. Mervine, E.M., K.W.W. Sims, S.E. Humphreys, and P.B. Keelman 2015. The applications and limitations of youth Discalbria systematics for determining rates of predicted carbonation in the Samayolophyllite Sultanate of Oman. Chemical Geology 412, 151, 166, Orget Errant, CA South. M.A. Seago, Kw Sims, and South. M. Aaron's 2017 Seasonal Progression of Uranium Series Isotopes in Subglacial Meltwater, Implications for Subglacial Storage Time. Chemical Geology 467, 4252, Topsoy Scott, S.R., Kelvin. W. Sims, B.R. Frost, P.B. Kelmank. A. Evans, and South. Swap 2017 on the hydration of olivine in ultramafic rocks, implications from Fe isotopes in serpentinites, Geochemica Cosmochemica Acta 215, 105, 215, Topsoid Jockey. Let's now enter the realm of core formation and planetary differentiation and discover the fascinating stories it has to tell. Newsom, H.E. and Kw Sims 1991. Core formation during early accretion of the Earth. Science 252, 926, 933. DOI, A Science. Sims, Kw, H.E. Newsom, and E.S. Gladney 1990. Chemical fractionation during formation of the Earth's core and continental crust. 2s from As, Sp, W, and Mo. In Origin of the Earth, J. Jones and H.E. Newsom eds. New York, Oxford University Press, Houston. Lunar and Planetary Institute. Newsom, H.E. Kw Sims, P.D. Knoll, W. L. Jagger, S. Amer, and T.B. Basra 1996. The depletion of W in the bulk silicate Earth, constraints on core formation. Geochemica et Cosmochemica Acta 67, 1155, 1169. DOI 4. Let's now turn our attention to development of novel analytical protocols and uncover the fascinating insights it brings to the table. Sims, Kw J. Gill, E. Dossetto, D. Hoffman, C. C. Lundstrom, R. Williams, L. A. Ball, D. Torstrup, S. P. Turner, J. Preit-Ulich, J. Glessner, J. J. Standish, and T. Elliott 2008. An inter-laboratory assessment of the isotopic composition of synthetic and rock standards. Geostandards and Analytical Research 32, 1, 6591. DOI, JEXEX. All, L.A., Kw Sims, and J. Schwieters 2008. Measurement of OO and Earth in volcanic rocks using the Neptune PIMMS. Journal Analytical Atomic Spectrometry 23, 173, 180. DOI, Abia. Lane, GD and Kw Sims 2000. Analysis of Earth in volcanic rocks by secondary ionization mass spectrometry. International Journal of Mass Spectrometry 203, 13, 187, 198. Dulayova, H. Kw Sims, and M. Ishret 2013. A new method for the determination of low-level actinium-227 in geological samples. Journal of Radioanalytical and Nuclear Chemistry 296, 279, 283. DOIS 122140. Lane Smith, D. and Kw Sims 2013. The effect of CO on the measurement of ERN with instruments utilizing electrostatic precipitation. Acta Geophysica 61, 4, 822, 830 Special Volume on Geohazards. Guest Editor, Rach Chandramola DOI, S13 107.3. Sims, Kw, and E.S. Gladney 1991. Determination of As, Sp, W, and Mo in silicate matrices by epithermal neutron activation and inorganic ion exchange. Analytica Chimica Acta 251, 297, 303. DOI 6. Sims, KWW, E.S. Gladney, C.C. Lundstrom, and N.W. Bauer 1988. Elemental concentrations in Japanese silicate rock standards, a comparison with the literature. Geostandards Newsletter, 12, 379-389. Choi, M.S., R. Francois, KWW Sims, M.P. Bacon, South. Lager Brown, A.P. Fleer, L.A. Ball, D. Schneider, and South. Hitchett 2001. Rapid determination of Earth and upper in seawater by inductively coupled plasma mass spectrometry. Marine Chemistry, 76, 99-112. In the upcoming section, we'll be shining a light on Peru, Cordillera Blanca. Nevado Huascarranza 6,768 meters. The west face via the Shield Salo, Nevado Chacraju 6,112 meters south face via American Direct, Nevado Artisan Raju 6,025 meters southwest face Solo, Nevado Tokloraju 6,032 meters, Nevado Chopacoki 6,354 meters, Nevado Copa 6,188 meters, Nevada Wamashraju 5,434 meters west face via Sims Hanning route first ascent. Get ready for an enlightening exploration as we dig into Ecuadorian volcanoes and understand its role in the broader context. Chimborazo 6,263 meters, Came 5,790 meters, Sangay 5,300 meters. Brace yourselves for the next chapter, where we'll be dissecting Alaska Range. Denali 20,320 feet. West Buttress as a guide, Moose Tooth West Ridge. Our focus now turns to Scotland, an important aspect of our discussion. Ben Nevis 4,406 feet. North Face. Orion Face Direct Grade 6.5 Gully Grade V Solo 0 Gully Grade V Solo. Craig Megadu 3,658 feet. North Face North Post Gully Grade V Solo. Moving on to the next segment, we have Colorado. Bridalveil Falls Grade 6, Ames Falls Grade 6, Skylight Grade V, the Squid Grade 6. Now, let's redirect our focus towards Utah and discover its significance in our narrative. Stairway to Heaven Grade V, Great White Icicle Grade 4. As we enter this new phase, let's uncover the impact of northeastern United States on our broader topic. The Promenade Grade 6, Repentance Grade 6, the Black Dyke Grade 4. Brace yourselves for the next chapter, where we'll be dissecting Yosemite Valley, California. El Capitan Pacific Ocean Wall VI 5.1 Salif Wall VI 5.11 Nose 6 Ear. Half Dome Northwest Face VI 5.11 6 hours, simultaneously climbing and almost all free. The Rostrum IV 5.11 Washington Column, Osterman IV 5.11 one-day combined ascent. Moving ahead, let's uncover the hidden gems within Black Canyon of the Gunnison, Colorado, and discover their significance. North Chasm View Wall A Voyage V First Free Ascent, Scenic Cruise IV 5.1, Journey Home 4, South Chasm View Wall Mirror Wall IV 5.11, Blackjack II 5.1. Painted Wall Southern Orit V 5.1, Mordor Wall VI 5.1. Get ready for an enlightening exploration as we dig into Longs Peak 14,110 feet, Rocky Mountain National Park, Colorado, and understand its role in the broader context. Longs Peak 14,110 feet, Rocky Mountain National Park, Colorado. The Diamond Grand Traverse, Yellow Wall V 5.9 A Winter Ascent, Casual Route 6, 5.9. As we enter this new phase, let's navigate the complexities of canyon country and discover its practical applications. The Witch Sims Hess Hanning Route, our first free ascent, Charlie Horse Needle Sims Hess Hanning Route, II 5.11 or Air First Free Ascent, Argonne Tower, Arches National Park, III, West Face First Free Ascent, Cochin Spire, Zuni Reservation, III, west face first ascent of tower. Welcome to the next segment, where we explore resources and its significance in our journey. Category: University of Wyoming. Faculty: Category: Living people. Category: Births. Category: American geochemists. Category: People from Colorado Springs, Colorado. If you want to see more videos like this, make sure to subscribe and turn on notifications.